Water is now poured into the other arm of the U-tube until the level of mercury in both arms are again the same. Calculate the height of the water column. Density of water equals to gram per cubic cm. Solution. Looking at the diagram, from the surface of separation A, the height of mercury Hm equals to 3 cm cube cm, while the height of kerosene Hk is not known. Let Hk be the height of the kerosene. Pressure at A equal to atmosphere plus Hk, height of kerosene, density of kerosene times acceleration due to gravity constant. Pressure at B equals to atmosphere plus height of mercury times density of mercury times acceleration due to gravity. Pressure at A equals to pressure at B. Therefore, Hk rho kg equals to Hm rho mg. Hk, making Hk the subject of the formula, you have Hm rho mg over rho kg, which is Hm rho m over rho k. Replacing the unknown values, we have 3 times 10.6 all over 0.8, which will give us 51 cm. Solution 2. Looking at the diagram from the point of separation, P and Q should be at the same level. Kerosene level should be at higher level than water. Let S be the height of water above mercury. Pressure at P equals to pressure at Q. Then pressure, as H rho G is equals to 25.5 times 0.8 times G equals to X times 1.0 times G. Making S the subject of the formula, we have that in bracket 51 times 0.8 all over 1, height of water X is equals to 40.8 cm. Hydraulic press. This is a machine which uses the principle that pressure is transmitted equally throughout a liquid. By using a lever, a narrow piston of small area A exerts a pressure P on a liquid. This is transmitted to a wider piston of large area A, which compresses a load. Example 3. A hydraulic press consists of 2 cylinders of cross-section 0.2 meters cube and 5.0 meters cube. If the position in the smaller cylinder is pushed down with a force of 100 Newton through a distance of 0.2 meter, calculate the pressure transmitted by the liquid, the force exerted by the piston by the larger cylinder. Solution. Pressure transmitted by fluid equals to force over area, which equals to 100 Newton over 0.2 meters cube, which is 500 Newton per cubic meter. Force exerted by a piston in larger cylinder equals to pressure times area, which is equals to 500 times 5, which will give us 2500 Newton. Example 4. The areas of the effort and load pistons of a hydraulic press are 0.5 meter cube and 5 meter respectively. If a force F1 of 100 Newton is applied on the effort piston, determine the force F2 on the load. Solution. Pressure transmitted by fluid equals to force over area, which is equals to 100 Newton over 0.5 meters cube, which is equals to 200 Newtons per meter squared. But large force on the large vessel equals to pressure times area, which is equals to 200 times 5, which will give us 1000 Newton. Pressure in liquid. 1. To show pressure varies from depth. Pressure at 1 is less than pressure at 2, and it's less than pressure at 3. Pressure is equals to rho g h, where rho is the density, g is acceleration due to gravity, h is the height. 2. Pressure is uniformly transmitted in liquid. 3. Pressure depends on density of material. The lighter the density, the lighter the pressure. Manometer is used to measure the difference in pressure. Barometer is used to measure atmospheric pressure. Manometer is used to measure the pressure difference between A and B, while barometer is used for measuring atmospheric pressure. Pressure is equals to rho g h, or density times acceleration due to gravity times height. To find the relative density of a material, pressure of S equals to pressure at Y. If pressure at S is rho, that is density of S times acceleration due to gravity g times height, which is h, is equals to pressure of water, or density, known density, which is p rho y, times acceleration due to gravity, which is g, times hy. Rho s times hx is equal to rho y times hy. To find the relative density, rho s over rho w equals to rho w over rho over h, where h, w, rho w, and hy are known. We can find the relative density of rho x. To test a barometer, the diagram A, B, and C must be equal to 760 mm mercury when tilted like that. Now it's time for revision examples. Question 1. A ball is thrown vertically upwards from the ground with an initial velocity of 50 meters per second. What is the total time spent by the ball in air? Taking our acceleration due to gravity equals to 10 meters per second. Solution. Using the first equation of linear motion under gravity, we have that V equals to U minus gt, where the time taken to reach the highest point is the same as the time to touch the ground from the highest point. At the highest point, V, that is the final velocity, equals to 0. 0, we now replace the unknown values. 0 is equals to 50 minus 10t. Then making t the subject of the formula, I have 50 over 10, which will now give us 5 seconds. The total time is equals to 2t, which is 2 times 5, which will now give us 10 seconds. Example 2. A stone is tied to a string is made to revolve in horizontal circle of radius 4 meters with angular speed of 2 radians per second. With what tangential velocity will the stone move